Welcome to SS2 Computer Science, Term 3, Week 14. Computer graphics is the field of computer science concerned with generating, manipulating, and displaying visual images and animations using computers. From the images on your phone screen to the special effects in movies, from medical imaging to video games, computer graphics is everywhere. By the end of this lesson, you will define computer graphics and identify its applications, distinguish between raster and vector graphics, understand the basics of 2D and 3D graphics, explain color models, RGB, CMYK, describe file formats for images, and answer WAEC questions on computer graphics. Let us begin. What is computer graphics? Computer graphics involves creating and manipulating images digitally, displaying them on screens, monitors, phones, TVs. Processing and transforming them, zooming, rotating, filtering. Animating them over time. Applications, user interface design, video games, films and animation, CGI, architectural visualization, medical imaging, MRI, CT scans, X-rays, scientific visualization, typography and publishing, virtual reality (VR), and augmented reality (AR), satellite imagery, graphic design. Two fundamental types of computer graphics: raster graphics, bitmap graphics. An image is represented as a grid of pixels, picture elements. Each pixel has a color value. The resolution, number of pixels, determines the image quality. File formats: JPEG, PNG, BMP, GIF, TIFF. Characteristics: pixel-based, zooming in reveals the grid of pixels, aliasing, jagged edges. Resolution dependent, a 100 by 100 pixel image has a fixed number of pixels, enlarging it reduces quality. Better for photographs and realistic images. File size depends on resolution and color depth. Editing, Photoshop, GIMP. Vector graphics, an image is represented as mathematical descriptions of shapes, lines, curves, and polygons defined by coordinates and equations. File formats: SVG, AI, EPS, PDF. Characteristics: resolution independent, can scale to any size without quality loss, no jagged edges, ideal for logos, icons, typography. Mathematical, defined by points, paths, and fill colors. Better for logos, illustrations, and text. Much smaller file sizes for simple shapes. Editing, Adobe Illustrator, Inkscape. WAEC key comparison: raster, pixel-based, loses quality when scaled up, JPEG, PNG, photos, Photoshop. Vector, mathematical shapes, scales without quality loss, SVG, AI, logos, Illustrator. Color models, ways of representing colors digitally: RGB, red, green, blue. Additive color model, used for screens and digital displays. Colors are created by adding different intensities of red, green, and blue light. Each channel has a value from 0 to 255. RGB 000 equals black. RGB 255,255,255 equals white. RGB 255,000 equals pure red. RGB 0,255,000 equals pure green. RGB 0,255 equals pure blue. RGB 255,255,0 equals yellow, red plus green. Y0 to 255. 8 bits, 1 byte, per channel 2 equals 256 possible values. 0 to 255, 3 channels times 8 bits equals 24-bit color, true color, 16.7 million possible colors. In web development, colors written as hex, hashtag FF0000 equals red, FF equals 255 red, 00 equals 0 green, 00 equals 0 blue. CMYK, cyan, magenta, yellow, key/black subtractive color model, used in printing. Colors are created by subtracting, absorbing, light. Ink on paper absorbs colors. What reflects reaches your eye. CMYK 0000 equals white, no ink. CMYK 0000100 equals black, cyan equals green plus blue, magenta equals red plus blue, yellow equals red plus green. YK key/black. Combining C plus M plus Y in equal amounts theoretically makes black, but in practice makes muddy dark brown. Pure black ink K is cheaper and more accurate. Conversion: digital files, RGB, must be converted to CMYK before professional printing. Colors may shift. Some bright RGB colors cannot be reproduced in CMYK. HSL/HSV, hue, saturation, lightness/value. Alternative color representation more intuitive for designers. Hue, the color type, 0 to 360 degrees on color wheel. 0 degree equals red, 120 degree equals green, 240 degree equals blue. Saturation, color intensity, 0% equals gray, 100% equals vivid. Lightness, 0% equals black, 50% equals normal, 100% equals white. Color depth, 1 bit, 2 colors, black and white, 8 bit, 256 colors, GIF, 16 bit, 65,536 colors, 24 bit, 16.7 million colors. True color, the standard for photos, 32 bit, 24 bit color plus 8 bit alpha or transparency, channel. 2D computer graphics, working with images in 2 dimensions, X and Y axis. Key concepts: coordinate system, origin, 0, 0, typically at top left of screen, X increases rightward, Y increases downward, in many screen systems. Basic shapes, primitives: point, line, from point A to point B, rectangle, circle/ellipse, polygon, multiple vertices, Bezier curve, defined by control points, used in fonts, logos, pen tool in Illustrator. Transformations, translation, move by dx, dy, shift to new position, rotation, rotate by angle theta around a point, scaling, resize by factor, sx, sy. Rasterization, converting vector shapes to pixels for display on screen. Anti-aliasing, technique to reduce jagged edges. If aliasing, in rasterized curves, blend edge pixels with background color. 3D computer graphics, working in 3 dimensions, X, Y, Z axis. Key pipeline, how 3D scenes become 2D images on screen. Modeling, create 3D models from vertices, edges, and faces, polygons, typically triangles. Rigging/animation, add skeletal structure for character animation. Texturing, apply 2D images, textures, to 3D surfaces. Lighting, add light sources, directional, point, spotlight, ambient, rendering, calculate what the camera sees, compute how light interacts with surfaces. Rendering techniques, ray tracing, trace rays of light from camera through each pixel into the scene, calculate reflections, shadows, refractions, photorealistic, very computation intensive, used in film VFX. Rasterization, project 3D scene onto 2D screen, faster than ray tracing, used in real-time rendering, video games, GPU accelerated. Software, Blender, a free, open-source 3D suite, Maya, Cinema 4D, 3ds Max, Professional, Unity, Unreal Engine, game engines with real-time 3D rendering. Image file formats, raster formats, JPEG, Joint Photographic Experts Group. Lossy compression, reduces file size significantly, loses some quality each time you save, ideal for photographs, does not support transparency, most widely used for web photos. PNG, Portable Network Graphics. Lossless compression, supports transparency, alpha channel, larger files than JPEG, ideal for logos, icons, screenshots, images with text. GIF, graphics interchange format, supports animation, only 256 colors, 8-bit, supports transparency, used for simple animations, very limited for quality images. TIFF, tagged image file format. Lossless, very high quality, large files, used in professional photography and printing. BMP, bitmap uncompressed, large files, simple format, rarely used for web. Vector formats, SVG, Scalable Vector Graphics Web-based vector format, can be embedded in HTML, edited with text editor, resolution independent. AI, Adobe Illustrator proprietary Adobe format. EPS, encapsulated PostScript used in professional printing and publishing. PDF, portable document format can contain both vector and raster elements, resolution independent for text and vector content. Lossy versus lossless compression. Lossy, JPEG permanently removes some data to reduce file size, significant reduction in size, cannot recover lost data, repeated saves reduce quality. Lossless, PNG, GIF compresses without losing any data, can be restored to exact original, smaller reduction in size. WAEC questions, define computer graphics, distinguish raster from vector, describe RGB and CMYK, calculate number of colors for given bit depth, name and describe image file formats, explain lossy versus lossless compression, give applications of computer graphics, draw and label a basic 3D graphics pipeline. Key points: computer graphics, creating, manipulating, and displaying images using computers. Raster graphics, pixel grid, resolution dependent, JPEG, PNG, GIF, BMP, photographs, Photoshop. Vector graphics, mathematical shapes, resolution independent, SVG, AI, EPS, logos and illustrations, Illustrator. RGB, additive, light, screens, 0 to 255 per channel, 24-bit equals 16.7 million colors, hashtag RGGBB in hex. CMYK, subtractive, ink/print, cyan, magenta, yellow, black, K added for accurate black. Color depth, 1 bit equals 2 colors, 8 bit equals 256, 24 bit equals 16.7 m, a true color, 32 bit includes alpha. File formats, JPEG, lossy, photos, PNG, lossless, transparency, GIF, animation, 256 colors, TIFF or lossless, professional, SVG, vector, web, PDF, or mixed. Compression, lossy, JPEG, smaller file, loses quality, lossless, PNG, perfect quality, larger file. 2D transforms, translation, rotation, scaling. 3D pipeline, model rig texture light render. Rendering, ray tracing, photorealistic, slow, films, rasterization, real-time, fast, games. Applications, games, films, CAD, medical imaging, VR/AR, graphic design. WAEC, describe raster versus vector, compare RGB and CMYK, name formats, explain compression, describe 3D pipeline, give applications.